Hi everyone. Today is Monday, October 24th. So today we're going to talk about session 4.7. We have some extra handouts of 4.7. If you need a copy, feel free and pick it up here. Okay, yes. And so this week we have a quiz on Friday. Okay, so the quiz is about session 4.1 to 4.6. And yeah, so please do your homework. And the homework due date for the second set of homework is on the Monday, right? On Monday, your homework from 3.5 to 4.7 is due. And yeah, so after today's class, we cover everything up to 4.7, and that's on your exam too. Then you can start to look at your practice exams, and so you first do it with pencil, and then you look at the solution to check your work. I want to ask you, so next week, Friday, we have exam, right? So our exam is from 12:20 to 1:50. And do you want to have some review sessions on the Wednesday nights? Okay, so do you want to be a virtual or in person review session? I'm thinking about the evening. So like evening at 8 o'clock, do you have time? Are you able to join virtually? Virtually. No? What time are you available? On Wednesday or Thursday? But I think Thursday is so close. I'm planning on maybe Tuesday or Wednesday, and then we can talk about if you have questions on some problem on the practice exam, we can go over that. So can you do it on Wednesday at 8 p.m.? If you can, raise your hand. How about Tuesday, 8 p.m.? Can you do that on Tuesday, 8 p.m.? No. So do you have a game or? Oh, you have work. Oh, so then.
Hang it on for like 9:30.
Oh, don't worry. We will record. Yes. Then you can watch the recording. Okay. So yes, right now let's have it on Wednesday, 8 p.m. Okay. So you know how to join TED Live? Go to Blackboard and click the TED Live. I will send you an email to remind you. Okay. So I hope you can do your practice exam before that, because on that day then we can go over some questions you have on the practice exam. Okay. Yes. Okay. So that is our plan. We're gonna try our best to do well on exam 2. Okay, so do your homework, study for the quiz and homework solution, other mistakes, and then the practice exam, do it multiple times. I told you some of my students do the practice exam 3 times. Okay, the first time is 1 week before the exam. So then you can know, okay, what type of problem is gonna be on the exam. Then you can review the notes about those type of problems, like the steps, how to solve those kind of problems. And you can find some other problems like similar problems to practice. And then you can do it second time, like 2 days ago before the exam. And then you do one more time the night before the exam to make sure you can remember all the steps. Okay, everybody? So I will send you an email about that. Okay, so today, yeah, we're gonna talk about sessions 4.7. So here we have some handouts of 4.7. If you need it, just come here and pick a copy. Okay, so 4.7, exponential and log models. So chapter 4, we talk about exponential function and the logarithmic functions, right? So today is gonna be application problems. Okay. By the way, when you do your homework, if you have any questions on some problem, please feel free to print screen the questions and then email to me, or you can post on the website's question sheets. Let's see. Do we have more questions on this question sheets? Okay, I guess not. All right. Okay, so exponential growth and decay. So the formula, okay, exponential functions applications. We learned something before, right? We learned compound interest, right? A equals P times 1 plus R over N. N is the number of compoundings. R is the annual interest rates. P is the principal. Do you remember that? And raise the power NT. So in the exam, we don't have formula sheets. So please make sure you can remember those formulas. Okay, so this is compound interest. And if we get compound continuously, then we use the formula P e to the RT. You remember that? Okay. And at that time, we also have like a homework. If it doesn't say like compound continuously, then we just use this one. Okay. And the end, because it doesn't say compound like many times a year, you just assume the number of compounding is one. So in that homework problem, we use the formula A equals to P times 1 plus R to the T. Do you remember that, everybody? So yeah, that is in the lecture when we talk about 4.1, and yeah, the next day we talk about the homework questions. Yes. Okay, so this is what we learned before. Now exponential growth and decay. So I would say let's look at this notation. So P, usually P stands for the population, and that equals P of 0. This is the initial population. Population times e to the RT. Then R is the growth rate. Okay, so R is the growth rate. And so P is the population function. It's a function of T. So I'm saying it's better to look at this, okay? So P is a function, population function. It's a function of T. And it equals to the initial population times D to the RT. R is the growth rate. If R is greater than 0, we have exponential growth. If R is less than 0, so the growth rate is negative, which means the population is decreasing. Yeah, so we actually have a decay instead of growth. Okay, everybody? So, example 1. In a research experiment, the population of fruit flies is increasing according to the law of exponential growth. So if you see this word exponential growth in the problem, that means you're going to use this formula. Okay? This is the exponential growth formula. After 2 days, there are 100 flies. And after 4 days, there are 300 flies. How many flies will there be after 5 days? So look at this formula. We have two parameters. First one is the initial population. The second parameter is the R, right? So usually we need two initial conditions to figure out these two parameters. That's why the problem says after 2 days, there are 100 flies. Oh, tennis. So today we use a new sheet. Okay? So please sign your initial, and let me also take a picture. Yeah, so from now on, I will take a picture. I will count like the number. Hi. Yeah, free time. So I will count the number of students in the picture, and then count the number of the signature on the sheet. So only sign on your spots. Don't help your friends to sign. Okay? So after 2 days, there are 100 flies. What does that mean? The population after 2 days is 100. Right, everybody? So T in this case T, the time, the unit is days. And after 4 days, there are 300 flies. So population after 4 days is 300. And our questions, how many flies will there be after 5 days? So the question is to find P of 5. We want to know the population after 5 days. So far, so good, everybody? Okay, now let's see. So we use the formula, P exponential growth formula. P of t equals P0 times e to the RT. Yes, sometimes we use the notation P subscript 0 to denote. So they mean the same thing, okay? So we want to find what is P0 and what is R, okay? So we use the initial condition. Okay, so this P of 2 equals 100. Let's put it in. So P of 2 is 100. P0 is unknown. R, we don't know that. T is 2. Is that okay, everybody? P of 2, see, we plug in T equals to 2. This is P of 2, and that is 100 equals to P0 e to the RT. T is 2. So we get this equation. So far, so good, everybody? Oh, by the way, we have some 4.7 handouts. If you need a copy, feel free to grab one. Okay? So, yeah, feel free to grab it. Yeah. All right. And next one. P of 4 equals 300. Write it down. So P of 4 is 300 equals, so we plug in T equals to 4, and P of 4 is 300. 300 equals P0, e to the R, T is 4. See, we have a system of equations, and we have 2 unknowns. So this 2 equations, we should be able to solve 2 unknowns. So how do we solve the unknown? Well, if you can remember, when we solve system of linear equations, we can do elimination or substitution. Elimination is you eliminate one variable and then you solve the other. Right? Substitution means you express one variable in terms of the other one, and then you plug it into the other equation. So in this case, let's say the first equation is equation 1. Second equation is equation 2. Do you see I can divide those 2 equations? Then I can eliminate P0. Yeah, everybody? Let me ask you. Shall I use equation 1 divided by equation 3, or equation 2, or use equation 2 divided by equation 1? 2 divided by 1. Yeah, then we have integer instead of fractions. So equation 2 divided by equation 1. So there are so many different ways you can solve a system of equations. So please write down what operation you are doing in each step so I can follow what you are doing. So we use equation 2 divided by equation 1. On the left-hand side, 300 over 100. Right, everybody? So 300 over 100. On the right-hand side, we have P0, e to the 4r, right? R times 4 is the same as 4r, over P0, e to the 2r. Is that okay, everybody? What's 300 over 100? 3. Oh, do you see P0 cancel? Yes? And do you see we can combine the e because the base is the same. What do? very good. So we use 4r minus 2r. So we're using the exponent rules, right? Okay, very good. What's e to the 4r minus 2r? Yeah, e to the 2r. So we know e to the 2r equals 3. How do we find the r? How do you get rid of the e? ln both sides. So ln of 3 is ln e to the 2r. Now do you see e and ln cancel? We get 2r, right? So therefore r equals what? ln of 3 over 2. Yeah? By the way, is this the same as ln of 3 half? Are they the same? No, don't combine them. They are not the same, so be careful, okay? All right, so this is r, okay? Then we can plug in one of the equations to find p0. Actually, do you see from equation 1, e to the 2r is 3. Yes, everybody? E to the 2r is 3. So let's plug this in equation 1. Okay, so we plug in here. We get 100 equals p0 times e to the 2r is 3. Yes, everybody? So what's p0? Is 100 divided by 3. Yes, everybody? Awesome. We get r and we get p0. Now we can put those into our population function. Okay, so p of t equals p0. P0 is 100 over 3. And then e to the r. What's r? ln of 3 over 2 times t. So far, so good, everybody? Yes, great. This is our population function. Yeah, we use the initial conditions to figure out the initial population. And we also figure out the growth rate r. Right? And what are we looking for? We want to find p of 5. Okay, so p of 5. That is, we plug in t equals to 5. Right, everybody? So we have 100 over 3. And e to the ln 3 over 2. T is 5. Okay, everybody, plug this in your calculator. So now you can watch the recording to make sure you finish those. So, yeah, put this in your calculator. What do you get? 100 over 3 times e to the ln of 3 over 2 times 5. And make sure you multiply the 5. This is still in the exponent of the e, okay? So this is still on the exponent of e. So parentheses, where your parentheses is also very important. What do you get? Oh, we have 520. Thank you. Okay, so this is 520. So we get 520 flies after 5 days. So far, so good, everybody? Okay, I want to ask another question. Okay? How many days? So, ask another question. How many days the number of flies will reach 1,000. Okay? Oh, sorry, 1,000. So, yeah. Well, our question is, we know the time is 5. We want to find the population. And now this question is the reverse way, right? We know the population is 1,000, and we're looking for the time. Okay, everybody? So in this case, we want to find the t such that, so we want to find the time such that p of the time is 1,000. Okay? And what is p of t? See? Look at this formula. We know this is P0, this is R, so this is P of t. P of t, and we set it equals to 1,000, and we solve for t, okay? So P of t is 100 over 3, e to the ln 3 over 2, t. This is P of t. We set it equals 1,000. By the way, can I cancel this e and ln? Can we cancel this e and ln? No, we cannot. Okay, because it's not just ln, it's also divided by the 2 and then times the t. So we cannot cancel it. We can only cancel it if it's e to the ln of this giant thing. Maybe a 3t over 2 is inside the parentheses. Then we can cancel it. But now, you see the 2 is outside of the ln, so we cannot cancel the e and ln. Yeah, everybody? All right. So this is an equation involving the exponential term, right? What do? Divide it by 100 and multiply by 3, right? So we isolate the exponential term first. So we divide it by 100 and multiply by 3. Oh, what do we get? 30. Yes? We want to solve for t. Do you see we already isolate the exponential term? How do we get rid of e? ln on both sides. Okay, let me zoom in. Okay, zoom in. We take the ln on both sides. So ln e to the ln 3 over 2t equals ln of 30. But on the left hand side, see, ln and e can cancel. So this is ln of 3 over 2t equals ln of 30. Yes, everybody? Can we solve for t now? What do? Multiply by 2 over ln of 3. By the way, can I cancel this ln 30 and ln 3 and say 10 is left? Can I cancel them? No, we cannot cancel them. By the way, if you have ln of 30 minus ln of 3, then you can combine them. See, ln combines subtractions into division. So 30 over 3. Ooh, can we cancel the 30 and 3 here? Yes, because now it's division. So this is ln of 10. So if we have subtraction, we can combine and then we have the division inside. We can simplify. But if we have ln 30 over ln of 3, that's it. You cannot cancel anything. Okay, everybody? They are not the same. See? They are not the same. So this is subtraction. This is division. They are not the same. So even though here the division is inside the ln. Okay, everybody? So be careful. I put this in your calculator. Give me 2 decimal places. 6.19 days. Thank you. Wow. So it increased quite fast, right? After 2 days, we get 100. After 4 days, 300. After 5 days, 520. After 6.19 days, ooh, we reach 1,000. Okay, everybody? Yes? Okay. So, yeah, your exam, you have some problem like that. All right. Let's keep going. Okay. Example 2. A certain radioactive isotope element, radium-226, decays exponentially. So if you see the word exponentially, that means we're going to use the formula, right? Our formula is P of T is the initial population e to the RT. Okay, so it's the same formula. Now we know the half-life. What's half-life mean? Okay, so this is radioactive decay, which means the population is actually decreasing. Yes, everybody, population is decreasing. Half-life means, okay, let's say T1 is half-life. If the population at T1 is half of the initial population. Half-life means we only have half of the material left. Okay, population decreasing, decay, right? So if the time such that the population is half of what we started. Okay, everybody? So this is the information. Half-life is 1,599 years. Given a sample with initial quantity 10 grams. So P0 is 10. That's initial population. What is the amount after 1,000 years? So our question is to find the population after 1,000 years. Okay, and we know the information, half-life. So that means the population after 1,599 equals half of P0. This is the information we have. Okay. So we already know P0 is 10. The half-life can help us to figure out the R. After we figure out the P0 and the R, we know the population function. Then we can plug in T equals 1,000. Is that okay, everybody? So, let's plug this in it. So plug this into our formula. Okay? T, we plug in T is 1599. Okay. And P of T, okay, is 1/2 P0. So we're plugging in here. We're plugging this formula. We let T equals 1599. And then this is P of 1599. And it equals to 1/2 P0. Is that okay, everybody? And on the right-hand side, we get P0. E to the R times, we plug in T is 1599. Is that okay, everybody? We plug in this formula. When T is 1599, P of T is 1/2 P0. Yes, everybody? Okay. Our goal is find the R. Oh, what can you do? Divided by P0, right? So divided by P0, we get 1/2 is e to the R times 1599. What do we do next? ln on both sides. Once we isolate the exponential term, we can apply ln on both sides. So ln of 1/2 equals ln of e r times 1599. ln e cancel. So R times 1599. What is R? R is yes, ln of 1/2 over 1599. Yes, everybody? Awesome. Okay, that's R. Great. Because now we have our P of T. See? We plug it back. What's P0? That is 10, right, everybody? P0 is 10, is given by the problem. E to the R. R is ln of 1/2 divided by 1599. And then T. We plug in our P0 and R into the original population function. Right, everybody? What are we looking for? P of 1000. So we plug in 10 times e to the ln 1/2 over 1599 times t. T is 1000. Questions? Can we cancel the e and ln? No. So please take out your calculator. Type this whole thing into your calculator. What do you get? Make sure you know how to use the calculator. Do you need, I have some extra handout over here. Oh, yeah. The one column. I have 2 more copies. Oh. All right. What do you get? Give me 3 decimal places. What do you get? 3 decimal places? Thank you. So we get 6.482 grams. And do you see this number is less than 10? Which means, oh, that makes sense. Because we have exponential decay, so the amount is smaller, smaller, smaller. And another thing, do you see this is bigger than 5 grams? Because the half-life is 1,599 years. So that means after 1,599 years, we only have 5 grams left. And 1,000 years is shorter than that. So the amount should be more than 5 grams. Yes, everybody? Okay, so this is the second example. We have exponential decay, right? Okay, log models. Okay, on the Richter scale, the magnitude R of an earthquake of intensity I is given by R equals log of I over I0, where I0 equals to 1 is the minimum intensity used for comparison. Find the intensity of each earthquake. Intensity of a measure of the wave energy of an earthquake. Okay, Alaska in 2012, the earthquake. R is 4. Okay, so part A, we plug in, right? We plug in R is 4, and we plug in I0 is 1. So we plug in the formula, R is 4, and that's log. If you don't see the base, that means your base is 10, exactly. We don't know I, but I0 is 1. Is that okay, everybody? Yeah? We plug R is 4 according to the formula. And the I0 is 1. That's given by the problem. Then, do you see? We get 4 equals log I. How do you get rid of the log? Apply base 10, right? Raised to the power of 10. So 10 to the 4 is 10 to the log I. You see? 10 and log cancel. I is 10 to the 4. So 10 to the 4 is 4 zeros. 10,000. So far, so good, everybody? Yes? Awesome. Okay, and then we have part B. Okay, now it's your turn to do part B. What do you get? I really our calculator because now the exponent is not an integer. Right. So part B, I is 6.3. 6.3 is log. I over 1 is I. So 10 to the 6.3 is I. What's 10 to the 6.3? Give me, integer. Give me integer. Just read the number. Thank you. Okay, everybody? Yeah, so this is the answer. Your exponent not need to be a integer, right? That's why the next exam you need to use your calculator. So please buy a calculator, scientific calculator, no graphing calculator. Okay. Any questions about this problem? Are we all good? Okay. Next one. Newton's law of cooling. The temperature of an object, T, in the surrounding air with temperature Ts. So Ts is the surrounding temperature. Will behave according to the formula. So capital T is the temperature, small t is the time. The temperature at time t equals A times e to the kt plus this is the surrounding temperature. Okay. A is the difference between the initial temperature of the object and the surrounding temperature. Okay, so that's why I love to use the notation T of T equals A. A is the difference between the initial temperature. Initial temperature is T of 0 minus the surrounding temperature, Ts. E to the KT and then plus Ts. K is a constant, the continuous rate of cooling of the object. So this is the formula. Okay. All right, let's keep going. A cheesecake. Do you like cheesecake? Yeah, we do. A cheesecake is taken out of the oven with with ideal internal temperature of 165 degrees Fahrenheit. Okay, and is placed into a 35 degree Fahrenheit refrigerator. After 10 minutes, The cheesecake has cooled to 150 degrees Fahrenheit. If we must wait until the cheesecake has cooled to 70 degrees Fahrenheit before we eat it, how long will we have to wait? Oh, so you're gonna do some math. You want to see good taste, tastes good after like 70 degrees Fahrenheit. That is good. Okay, so think about that. Think about that. Let me put it right here. Okay, let's think about two story. This is the refrigerator. Okay, and let's say here we have a cake. We want to put into the refrigerator. In this case, the initial let's say room temperature is 72 degrees Fahrenheit. Like the temperature in the refrigerator is like 35 degrees. Okay, so in this case, what is the T0? What's the TS? Look at this story. We have a cake in room temperature, so 72 degrees. So this is not related to our problem. I just want to ask you, if we have a cake in room temperature, 72 degrees Fahrenheit, and then we want to put it inside the refrigerator, what is your initial temperature of the cake? 72 degrees Fahrenheit. Okay? And what's the surrounding temperature? 35. Once you put inside the refrigerator, the surrounding temperature is 35. Right, everybody? Okay, now, how about we have the cake in the refrigerator, but now you want to take it out. What is your initial temperature? 35. What's the surrounding temperature? 72. Okay. So you gotta read the problem carefully. Sometimes it's very easy to confuse like which is which. Which one is the initial temperature? Which one is the surrounding temperature? So you want to say, oh, you want to put the cake into the refrigerator, or you want to take it out from the refrigerator. Okay? So now come back to our problem. We have so it's taken out from the oven with the temperature. What is the 165 degrees? Is this initial temperature or the surrounding temperature? Initial. So T of 0 is 165. Then what is the 35? TS. The surrounding temperature is 35. Okay? After 10 minutes, the cheesecake has cooled to 150. So the temperature after 10. Here the time, the unit is minutes. Okay? So T of 10 is 150. And our questions. We want to find how long. How long means we want to find the time such that the temperature at that time is 70. Okay, so we read the word problems and convert the English sentence into math symbols. We figure out what we have, what condition we have. Okay, and we want to figure out what's the goal, the question. We find the time such that the temperature at that time is 70. Okay, very good. Now we use the formula. Okay, so the formula is right here. Let me copy down. So T of T is T of 0 minus Ts e to the kt plus Ts. So this is the formula. Okay, here, how many parameters are there? Well, T0, but we know what's T0, right? Ts, we know what's Ts. So the only unknown is the K. So this information will help us to find the K. Okay, everybody? We plug in time is 10. Then T of 10 is 150. Yes, everybody? we plug in. So we get, please write tiny because it's a long problem. So T of 10 is 150. So far so good. Okay, what's T0? 165. TS 35. E to the K we don't know. We're looking for K. What's the T? T is, see, 10. Yeah, we plug in here, right? So T is 10. TS 35. Right, everybody? We plug in T is 10, and then T of 10 is 150. So we want to find the K. So we isolate the exponential term. Let's subtract 35 on both sides. What's 150 minus 35? 115, yeah. What is 165 minus 35? 130. E to the K times 10. What do we do next? Yeah, divided by 130. So 115 over 130 is e to the K times 10. Right, everybody? Uh-huh. Oh, what do we do next? ln. So ln, by the way, can we simplify 115 and 130? Do you see the common factor 5? Yeah. What's 115 divided by 5? What? 23 over 26. Thank you. By the way, you don't have to simplify it. Okay, you don't have to simplify it. So ln of 23 over 26 is ln e to the K times 10. Do you see e and ln cancel? So 10K. What's K? ln of that divided by 10. Okay, so when you work with the ln, you're going to be very, very careful. You want to ask, is this number inside the ln or outside of the ln? Yes, so be careful. Okay? So that is the K. Good. Now we can plug in. See? Now we can plug in to our formula. So T of T is T0. What's T0? 165 minus TS. What's TS? 35. E to the K. You see? K. We can plug in ln of 23 over 26 over 10 times T plus TS. What's TS? 35. Yes, we plug it back here. T0, 165, TS, 35, e to the K. By the way, can we cancel the e and ln? No, don't do that. And yeah, plus TS, 35. Okay. We are looking for the time such that T of T is 70. Yes, everybody? So we set this guy equals to 70, and we want to solve for T. Right, everybody? If the problem asks you, what's the temperature after 1 hour? Well, then you're going to be careful. What's the unit of the time? Minutes. So 1 hour is 60 minutes, right? So if you're looking for the temperature after 1 hour, you plug in T of 60. Okay, everybody? But here is asking all the time, so that the temperature is 70. So we plug in this is 70. Again, what's 165 minus 35? 130. Okay. E to this ln 23 over 26 over 10 t plus 35. Okay, we want to find the t. So what do we do? Minus 35. What's 70 minus 35? 35. Yeah, so it's 35 is 130 times e to the, can I put this thing into a box? Can I do that? You know what the box is, right? Yes? Okay, and what do we do next? Divided by 130. So we have 35 over 130 equals e to the box t. Yes? What do we do next? ln. So ln of 35 over 30. Do you see ln and e cancel? Okay, now it's the time to put our box back. Our box is 23 over 26 over 10 t. Yes, everybody? So if in the exams, if you use a box, I'm fine with that. As long as you know it's that thing, but you don't want to carry that everywhere to copy it, then you can use the box. Okay, everybody? So, what's the t? This ln of 35 over 30. 130, thank you. And then we divide it by the ln of 23 over 26, and then times 10, right? A question. Can we cancel the 130 and 26? No, we cannot. Okay? Because this division is outside of the ln. You cannot cancel. So you type this whole thing in your calculator. So only use your calculator at the last step. So in the middle, right here, don't plug in your calculator and give me decimal because that is not exact. Okay, everybody? You hear that? Only use your calculator at the last step. What do you get? Give me whole number. 107 minutes. Oh, so yeah, 7 minutes after 1 hour. Then the temperature will cool down to 70 degrees Celsius. So far, so good, everybody? So I would say that the temperature problem could be the hardest example. Okay? Yes. Good. Other models. Example 5. Have you taken chemistry? Yeah? So acidity models pH. pH is minus log of, this is the concentration of the hydrogen ions measured in moles of hydrogen per liter. Okay? Of a solution. So we want to find the pH. If the hydrogen ion concentration is 2.3 times 10 to the negative 5, find the pH. And also compute the hydrogen ion concentrations when the pH equals 5.8. Have you done something like this before in your chemistry class? Not yet? Okay. But have you heard about pH? Yeah, you know, pH 7 is neutral, right? Yeah, okay. Good. So, part A. Find the pH. So this is a formula. Bless you. This is a formula. Now we want to plug in. So pH is minus log the hydrogen ion concentration is 2.3 times 10 to the negative 5. Right? We plug in this hydrogen ion concentration is 2.3 times 10 to the negative 5. Plug in your calculator. What do you get? Give me 3 decimal places.
4.63.
Thank you. Right, everybody? So this direction is easy. We just plug in the formula and then we get that. And part B. Compute the hydrogen ion concentration when the pH is 5.8. See? pH is 5.8. We plug into that formula. pH is 5.8 equals minus log of the hydrogen ion concentration. So what do we do? How do we solve for this? What do you do with the minus sign? Divide by negative 1. So we get minus 5.8 is log. So we first isolate the log term. How do you get rid of the log? Yeah, apply 10 to the, so negative 5.8. This 10 to the log. 10 log cancel. Okay, use your calculator. What is 10 to the negative 5.8? Give me 3 decimal places. After, yes, so then it's like 3 significant digits after the decimal. What do you get? Yes. Yes. So this scientific notation. Give me like here like 3 decimal places after that. But using the scientific notation. So far so good, everybody? Okay. Good. So your calculator give you decimals or your calculator give you scientific notation? Decimals. Oh, okay. Then you count how many zeros in front of that, right? So your calculator might give you 0.000001585 something. So you see, you move your decimal 1, 2, 3, 4, 5, 6. 6. That's why it's 10 to the negative 6. Okay? Are you good with like scientific notation conversions? Okay, good. All right, so we still have some time. I want you to try the problems on your practice exams. So now we have like covered all the topics on your exam too. So you should be able to work on your exams. Okay, so let's try this problem. You try this problem now, and then when you after you review everything, you can work on your practice exam again and try it. If this is hard to find, or you can change the numbers and work on it. Yeah, the number of rabbits in the farm is increasing according to the law of exponential growth. The new population is 200 rabbits, and the population after 6 months is 700 rabbits. How many rabbits will be there after 1 year? 8. How many months are there in a year? Who forgot to sign it? Oh, I see. So our initial this we follow this number and we just initial information to okay, we T0 is and then information after six is seven. We can find the new information. Yes.
Yeah, right.
Initial condition means time t. Therefore, e is equal to 0. And this is answer is 2450. Right?